All right, so just as a reminder, we do have our test coming up tomorrow over 7-1 to 7-3. For the first question, you do not have to write the original problem down. Go ahead and start working it out. It says, find the probability of the compound event, round to the nearest whole percent. So for this problem, it says that you roll a number on a number cube and you spin the spinner. What's the probability of rolling an odd number and landing on a 4? So what's the first thing we're looking for here, class?
Rolling an odd number.
Rolling an odd number. Okay, so let's look down here at this. How many odd numbers are there on the number cube? 3 out of how many? 3 out of 6. That's my first event. Let's check on the second event. Landing on a 4. Now we're focusing on the spinner right here. How many are there 4s on that one?
1.
There's only 1 out of how many numbers?
5.
1 out of 5. Okay, so what should I do to those two since this is a compound event? Multiply it together. When you do that, what do you get? 3/30. If I reduce it, I would get 1/10, which is 10%. Okay, so we could see that there would be a 10% probability of this happening. All right, number 2 is still doing the same kind of idea. We are finding the probability of the compound event and make sure you round to the nearest whole percent. All right, this one's just a little bit different. We are rolling a number and still spinning the spinner, but what's the first thing we're looking for here?
Rolling a 6.
Rolling a 6. Guys, how many 6s are there on a number cube? 1 out of how many numbers?
6.
A 1 out of 6 chance of that happening. Next, I want to see if I can land on a 5. How many 5s do you see here on the spinner? 1 out of how many total numbers? 5. What do I do to those two fractions? Multiply them. 1 times 1 is? 6 times 5 is? 30. What is 1 divided by 30? Okay, now we've got to turn this into a percent. Okay, so now I've got 3.3 repeating percent. Okay, I want that rounded to the nearest whole number. The whole number is checking. Should it bump up or stay the same? It's going to stay the same. So what's my answer? There is a 3% chance that that would actually happen. For question number 3, it's asking us to use the percent equation to solve. So the first thing I'm wondering, guys, what is the percent equation? P times of equals is. Very good. Then we want to make sure that we're separating into the 3 different parts. What should I underline first of the original problem? 65 is. What should I circle? What percent and what should I underline? Very good. Okay, so remember, once again, we're just splitting it into the is, the of, and the P. First things first, guys, what's our P? We don't know it, so we're going to keep it as a P. What's my of? 13. So I've got to multiply it by 13. And what's my is? 65. Guys, how do I get P by itself? Divide by 13 on both sides. When you do that, what do you get? P equals 5. Now here's the deal. This is what a lot of people forgot on their quiz. It says what percent. So you simply just need to add units, and the answer is 5%.
Wait, what if you just put 5%?
So for problem number 4, it says there are many different kinds of chips in this box. 16 Cheetos, 18 Ruffles, 12 Fritos, 4 Lay's, and 9 Funyuns. What is the theoretical probability of choosing Cheetos round to the nearest 10th percent? Help me with this first thing, guys. What is the theoretical probability formula? All right, very good. So we want to have favorable over total. What does favorable mean?
Like in your favor. It's what you want.
It's what you want. It's what you're looking for. What are we looking for on this problem?
Cheetos.
Cheetos. How many Cheetos are there?
16.
16. So that's what's favorable because there are 16 Cheetos. Divided by, how many total were there? 16 plus 8 plus 12 plus 4 plus 9. Here's what happened on the quiz. A lot of people multiplied all those together. But let's think about it. If I want to know how many kids are in our class, and there's 5 boys and 7 girls, how many total students are there? 12. You just add them together. Don't multiply them. Add them. Okay, so when we add all those chips together, how many total chips were there? 49 of them. Okay, so you got to divide 16 divided by 49. When you do that, you get 0.3265 3, kind of goes on, right? Now remember, we've got to turn this into a percent. So we move that decimal 2 places over, giving us 32.653%. Do you think that's my answer?
No.
No, I have to round it to the nearest what? 10th percent, all right? What's the tenths place there?
5. 6.
The 6. The 6 asks his neighbor, are you 5 or bigger? What's that 5 say?
Yes.
Yes, so what happens to 32.6?
The 6 turns into a 7.
It becomes 32.7, okay? A lot of people are still rounding to the nearest whole number. Make sure you have a tenths place if it asks for rounding to the nearest 10th percent. Okay, so for problem 5, we are finding the selling price. As I walked around, I saw different people had 2 different ways that they found this answer. One way, we want to remember to use the formula P times of equals is. What percentage does it tell us the discount is there? 60%. Okay, change that to a decimal, and what do you get? 0.6 times, what's the original price? 82. When you multiply those 2 together, what do you get? $49.20. Is that the new price? No. What is $49.20? That's the discount. That's how much you get off. All right. Quite a few people left it at $49.20. Please remember that's just the amount that you get off. So what do I have to do with that $49.20? Subtract it. The original price was $82, and then you're going to subtract $49.20, and what do you get?
$32.80.
Okay, very good. Now, there's another way to do it that I saw some other people. Remember, the price is normally 100%, but how much of a discount are they taking off? They're taking off 60%. So what price do they actually have to pay? Or what percentage? 40%, okay? Now, this is the price that or the percentage we have to pay. So if I want the answer real easy to tell me just how much I have to pay, I would take 0.40 and multiply it times that $82. If I do it that way, the answer comes right out as what? $32.80. Notice you get the same answer either way. I do not care how you find the answer. Either one of those would be fine with me. For this one, it asks us to use the fundamental counting principle to find the total number of possible outcomes. So remember, the method we're using here is fundamental counting principle. What do we have to remember to always do when we have the fundamental counting principle? We're going to multiply. So here's what it says. Your pantry contains 5 boxes of pasta, 6 jars of spaghetti sauce, so we have to multiply these, 2 bags of cheese, and 5 kinds of seasoning. When you multiply all those together, guys, what are the possible outcomes? Okay, 300. Remember, you want units attached, so 300 possible outcomes is correct. Number 7 says to describe the likelihood of the event. So we know some different words for likelihood. It says the probability of an event is 15 out of 20. Guys, what's 15 out of 20 as a decimal? 0.75, okay, which means, as you guys just said, 75%. Guys, what's the likelihood of something is 75%? That is definitely likely, okay? Or you could even say very likely. All right, for this one, we are finding the experimental probability of the number cube. Guys, what's the formula for experimental probability?
Success over trial.
Very good. Successes divided by the number of trials. So for this problem, guys, what are we looking for? An even number. Look down there. Okay, it looks like a number cube. They're rolling a number cube. How many numbers are on the number cube?
6.
There's 6 of them. Out of 1 through 6, which one of those numbers are even numbers? 3 of them. Which ones?
1 through 12. 2.
2, 4, and 6. Okay, how many times did they roll a 2?
53 times.
53. How many times did they roll a 4?
52 times.
And how about a 6?
48 times.
Should I multiply those together or add them?
Add them.
You're going to add them. When you add those together, how many successful times did they get an even number? 153. Out of, we want to add all of these numbers that are there. How many total trials were there?
300.
Out of 300 tries. What would that be as a decimal? 0.51. As a percent, it would be 51%.
Wait, is this the same
All right, for problem number 9, You are finding the experimental probability of the number cube, and you're trying to see how many times you rolled a 6. Once again, we're doing experimental probability. What is the formula? Successes divided by the trials. How many times did they successfully roll a 6?
48 times.
Okay, 48 times. Out of how many total trials? Divided by 300. Okay, when you do that, you get 0.16. What percentage is that? 16% of the time they rolled a 6. All right, for this problem, you deposit $800 in an account. The account earns $360 simple interest in 3 years. What is the annual interest rate? Guys, what's the formula I need to use for a problem like this? I equals PRT. So we're trying to find the I, the P, the R, and the T. All right, let's focus on the first sentence. It says you deposit $800 into an account. Guys, what is that $800?
Principal.
That's the principal. That's my starting amount. That's $800. As you keep reading, the account earns $360 simple interest. So that right there tells me that that is my interest, the I. And I do this in what amount of time? In 3 years. So 3 years, is that the rate or the time? Okay, that's the time. Okay, so we're going to put that down there. Do we know what the rate is? No, we're looking for the rate. So we're just going to put a question mark. Okay, so once again, off to the side, I'm going to start with I equals PRT. What is my I? 360. What's my P? 800. What's my R? We don't know it, so we're going to keep it as an R. And what's my time? 3. There's nothing I could do on the left side, but there's something I can do on the right side. What can I do? Multiply 800 times 3. Okay, so then I'm left with 360 equals, what is 800 times 3? 2,400, and bring down the R. A lot of times people are leaving that variable off and then they don't know what to do. Okay, so you're going to put times R. How do we get R by itself? Divide by 2,400 on both sides. When you do that, you find out that R equals 0.15. But your rate always has to come out as a what? A percentage. So what's the answer? This is going to be 15% rate. All right, so just remember, tomorrow is our test, once again, over sections 7.1 through 7.3. So make sure you study tonight.